Dear students, so in this class, now let us discuss about the power series solution and special function. So what is a power series and special function? Special function means it is nothing but the solution of different types of differential equation or integral equation. So H function is a special function. Incomplete gamma function, that's a special function. Gamma function is also a special function. Legendary polynomial, Legare polynomial, Bessel's polynomial, etc. are special functions. So first we discuss about the power series. What is a power series? So an infinite series is of the form sigma n ranges from 0 to infinity a n x power n. The infinite series sigma n ranges from 0 to infinity a n x power n is called, that is a0 plus a1x plus a2x square plus etc. a n x power n plus etc. is called a power series in x. That is called a power series in x. So here sigma n ranges from 0 to infinity a n x minus x naught all power n, which is called the power series in x minus x naught. Agreed. Then, so consider this power series. Sigma n ranges from 0 to infinity a n x power n. So the power series is said to be converges if limit n tends to infinity, sigma n ranges from 0 to m a n x power n exists. The power series sigma n ranges from 0 to infinity a n x power n is said to be converges only when limit n tends to infinity, sigma n ranges from 0 to m a n x power n exists. Then the limiting value of this power series, the limiting value, the value of this limit is said to be the sum of the series. This is the sum of the series. That is the value of this limit or the limiting value of this one. Limit n tends to infinity, sigma n ranges from 0 to m a n x power n. So the limiting value is said to be is nothing but it is the sum of the series. Okay. Then for each power series, sigma a n x power n or sigma a n x minus x naught all power n, whatever may be, for each power series corresponds to a positive real number r. R is any real, R is a real number, it is greater than 0, positive real number. It may be sufficiently large, whatever may be. So for each power series there exists a positive real number r in such a way that the series converges when mod x less than r. The series converges for mod x less than r, and the series converges for mod x less than r, and it is diverges when mod x greater than r. It is diverges, the power series diverges for mod x greater than r. So what is r? Here r is said to be the radius of convergence. Radius of convergence. So that's a familiar result. What is radius of convergence? We know that r equals limit n tends to infinity modulus of a n by a n plus 1. So this is the radius of convergence of a power series. That is familiar with you. We have already studied about that one in complex analysis as well as real analysis in degree final year. Okay. So here the power series converges for mod x less than r and diverges for mod x greater than r, where r is any real number which is positive. Then this r is said to be radius of convergence. So each power series in x has a radius of convergence 0, each power series in x. So sigma n ranges from 0 to infinity a n x power n is a power series in x. This is a power series in x minus x naught. So each power series in x has a radius of convergence r with a 0 less than or equals r less than or equals infinity. 0 less than or equals r less than or equals infinity with the property that the series converges for mod x less than r and the series diverges when mod x greater than r. So, if r equals 0, so there is no x satisfies mod x less than r. There is no x satisfies mod x less than r. Means, when r equals 0, the series diverges. If r equals infinity, there is no x satisfies mod x greater than r. That means, when r equals infinity, the series converges. There is no x satisfies. If r equals 0, there is no x satisfies mod x less than r. We already say that, or we say that, when mod x less than r, the series converges. So if r equals 0, there is no x satisfies mod x less than r. So it simply means that, or we can understand that, series diverges. If r is infinity, there is no x satisfies mod x greater than r. Also we know that when mod x greater than r, the series diverges. So when r equals infinity, the series converges. Okay. So, if r is finite and non-zero, it may be negative or positive. R is only a positive real number, not negative, If r is finite, not infinity. If r is finite and r differs from 0, if r is finite and non-zero, then it will determine an interval of convergence. Interval of convergence means minus r less than x less than r. R is a positive real number. Then, if r is finite and non-zero, then it always determines an interval that is x lies in between minus r and plus r. So this interval is said to be the interval of convergence. So, if the series inside this interval means minus r, so consider minus r and r. So inside this interval the series converges and outside of this interval the series should diverge. So this is the interval of convergence. R is the radius of convergence. So if r is non-zero and it is finite, then it always determines an interval. That interval is known as interval of convergence, and inside this interval the series always converges, and outside of this interval the series always diverges. Okay. Then consider a function f of x. You consider a function f of x with the property that a power series expansion of the form f of x equals sigma n ranges from 0 to infinity a n x minus x naught all power n. Consider a function f of x equals sigma n ranges from 0 to infinity a n x minus, means the function is nothing but the infinite, it's an infinite series in x minus x naught. That's a power series in x minus x naught. So, a function f of x is the property that the power series expansion of the form f of x equals sigma n ranges from 0 to infinity a n x minus x naught all power n is valid for some neighborhood of x naught, then is said to be it is analytic at x naught. The term analytic, we are so familiar with it. Analytic at x naught. What is analyticity? You know that what is an analytic function? That's familiar with you. So in previous years in complex analysis, we are studied detail in analyticity at a particular point and in a given interval. So what is the analyticity of a function? So if f of x is nothing but a function which is expressed in terms of power series, it is expressed as a power series in x minus x naught, then which is valid for some neighborhood of x naught, then the function is said to be analytic at the point x naught. So what is a n here? Here a n is fn x naught by n factorial. Fn x naught by n factorial. Hence this expansion is said to be So which is the Taylor series. It is said to be the Taylor series of f of x at x naught. An is fn x naught by n factorial. So you can find out its remainders and so on. All of these things are studied in previous years in real analysis as well as in complex analysis. Okay. So this is the Taylor series form. An is fn x naught by n factorial, where f of x is sigma n ranges from 0 to infinity, an x minus x naught all power n, which should be analytic at some point x naught. Clear? Now let us discuss a problem. If P is a non-zero positive integer, P is a P differs from 0, but it is, so P is a non-zero positive integer. Non-zero P. Simply you can write it as this way. P is non-zero positive integer. Then the series sigma n ranges from 0 to infinity, P into P minus 1 into etc. into P minus of n minus 1 all divided by n factorial into x power n. It converges for mod x less than 1 and diverges for mod x greater than. Consider the power series. Sigma n ranges from 0 to infinity, P into P minus 1 into etc. into P minus of n minus 1 by n factorial into x power n. So we have to show that it converges when mod x less than e1 and diverges for mod x greater than. So how? In order to prove the convergency under a particular value, so first we have to find out its radius of convergence. We know that the power series sigma n x power n converges for mod x less than r and diverges for mod x greater than r, where r is a positive real number which is known as its radius of convergence. So here we can find out the radius of convergence. What is r? We know that r equals limit n tends to infinity of modulus of an by an plus 1. Okay. Here what is an? This is an. So what is here an is p into p minus 1 into etc. into p minus of n minus 1 all divided by n factorial. This is an. Okay. So what is an by an plus 1? An by an plus 1 is n plus 1 factorial divided by p into p minus 1 into etc. into p minus of n minus 1 into one term remains there, which is p minus n. Clear? So what remains? So that equals n plus 1 factorial by n factorial is n plus 1 divided by p minus 1. All the other terms are cancelled. Therefore, that means r equals limit n tends to infinity of n plus 1 by p minus n. So it is simply it is 1. Okay, that is limit n tends to infinity, take n outside, what you get? N into 1 plus 1 by n divided by, it is n into p by n minus 1. So applies the limit, so it is 1. Okay, so r equals 1. The radius of convergence is 1 here. So what is the interval of convergence? Minus, open interval, minus 1. Here r is 1, so we know that the series sigma an x power n converges for mod x less than r and diverges when mod x greater than r. So it is converges for mod x less than 1 and diverges for mod x greater than 1. Clear? No. So come to another one. Prove that. So consider another series. Let y equals. Prove that. Let y equals 1 minus x square by 2 plus x power 4 by 2 square into 4 square plus minus x power 6 minus x power 6 by minus x power 6 by 2 square into 4 square into 6 square plus etc. Okay. Then prove that it converges for all x. It converges for all x. That's our requirement. Prove that it converges for all x. Also it satisfies a differential equation x y2 dash. Also it satisfies the differential equation x y2 dash plus plus y dash plus xy equals 0. X y2 dash plus y dash plus xy equals 0. How to solve this one? First we show that the given series converges for all x. So for how? What is y? The answer is, what is y here? Y equals 1 minus x square by 2 plus x power 4 by 2 square 4 square minus x power 6 by, not it is 2, it is 2 square, sorry. X minus x power 6 by 2 square 4 square 6 square plus etc. So first we find out its nth term. So what is y here? Y is sigma n ranges from 0 to infinity. So it's an alternative. So it is minus 1 power n. Since it is ranges from where to where? 0 to n. So it is minus 1 power n. Then x square, second term involving x square. So it is x power 2n divided by, it is 2 square, 4 square. Okay, 2 square into 4 square into 6 square into etc. into 2n whole square. Okay, 2n whole square. So that means that equals sigma n ranges from 0 to infinity minus 1 power n x power 2n divided by, so it is 2 square 4 square etc. 2n whole square means 2 power 2n into n factorial whole square. Okay. 2 square 4 square 6 square etc. 2n whole square. So it is 2 power 2n into, again 1 square 2 square 3 square etc. So it is 1 2 3 etc. to n whole square. So it is n factorial whole square. Therefore, so what is R equals limit n tends to infinity modulus of an by an plus 1. What is an? So this is an. Okay. So it is sigma an x power n. So what is an? An is minus 1 power n by this one. So it is limit n tends to infinity modulus of minus 1 power n by 2 power 2n into n factorial whole square into an plus 1. 2 power 2n plus 2, 2 into n plus 1. Okay, into n plus 1 factorial whole square all divided by s minus 1 power n plus 1. Okay. So what do you get? So finally we have, if you apply the limit minus 1 power n plus 1 whatever may be, 2 power 2n, 2 power 2n plus 2, so it remains 2 square. So on numerator there is n plus 1, so its value is infinity. So here R equals infinity means the radius of convergence is infinity. We know that if R equals infinity, there exists no x satisfies, there is no x satisfies mod x greater than R. That means the series converges for all x. That means it converges for all x. That is the first part. Okay. Since R is infinity, so we can say that, we can conclude that since R is infinity, there exists no x satisfies mod x greater than R. That means the series converges for all x. Agree. So come to the second part. Second part is immediate. So you can prove that the series satisfies the differential equation x y2 dash plus y dash plus xy equals 0. That's, you can directly substitute for what is y. That y equals sigma n ranges from 0 to infinity minus 1 power n, or simply 1 minus this way, 1 minus x square by 2 square plus x power 4 by 2 square into 4 square minus x power 6 by 2 square, 4 square, 6 square minus plus etc. So what is y dash? Y dash is, we can find out y dash, y2 dash and xy2 dash. Then you can substitute all of these things in this relation. So you may get answer is 0. Okay. So you can supply the values of y dash, y2 dash and xy dash, xy in the given equation. So we can satisfy xy2 dash plus y dash plus xy equals 0. You see, you can say that xy2 dash plus y dash plus xy equals 0 means this y, this infinite series, so this power series should satisfy this differential equation. Okay, thank you.